this video, we are going to learn how to find the limit of a two-variable function with multiple examples. The first example is, what is the limit of this function at 2, 1? Basically, we need to find this function is approaching to what value whenever x is approaching to 2 and y is approaching to 1. So simply first we will check it by substituting the value of x and y, whether we are getting a finite value or not. In this case, when you put x is equal to 2, we have 3 into 2 plus 4 into 1. And this is equal to 6 plus 4, that is equal to 10. And that is a unique and finite. So this implies limit exists and value is 10. Next example, what is the limit of this function when x comma y approaches to 1 comma minus 1? Means when this ordered pair approaches to this point, what is the limiting value at that point? So x is approaching to 1, y is approaching to minus 1. So substitute in this case, that is 1 cube minus 1 cube divided by 1 minus 1. This is equal to 1 minus 1 divided by 1 minus is plus 1. This is equal to 2 by 2 and this is further is equal to 1. Limit is finite and unique. We can say that limit exists and the value is 1. Next example, we have this form x cube minus y cube divided by x minus y. And we need to find the limit of this function at the point 1 comma 1. Means when x is approaching to 1 as well as y is approaching to 1. In that case, what is the limit in this case? When you substitute x is equal to 1 and y is equal to 1, what we have? 1 minus 1 divided by 1 minus 1. That is a 0 by 0 form. And that is undefined. We need to use some another approach. Observe that this is the x cube minus y cube. We can find its factorized form. So we have in this case as x minus y into x square plus xy plus y square divided by x minus y. So we can write this function in this form. And in this case, limit x is approaching to 1, y is approaching to 1. This factor is get cancelled with this one. Finally, we have this form. Now substitute x is equal to 1 and y is equal to 1. We have 1 plus 1 plus 1, that is equal to 3. It means this function is converges to 3 whenever x comma y is approaching to 1 comma 1. Next example, find the limit of this function at the point 4 comma 3. Means whenever x approaches to 4 and y approaches to 3, what is the limiting value of this function? Substitute x is equal to 4 and y is equal to 3. Even in a denominator, numerator is equal to 0, even denominator term 0. So it is again 0 by 0 form. So in this case, we need to use some other approach. Observe this function. In this case, we have x minus y minus 1 and in this case, x minus y root minus 1. We have one option to create it as a factor form. So we need to find the factor of this one in terms of this or its factor in terms of numerator. We can write this as equal to root of x minus y square minus 1 square divided by root of x minus 1 minus 1. And this limit x comma y is approaching to the point 4, 3. In numerator, we can use the identity a square minus b square is equal to a minus b into a plus b. Simplify this, we have limit x comma y as approaches to 4 comma 3 This can be written as x minus y root minus 1 into root x minus y plus 1 divided by root of x minus y minus 1. Now this factor is get cancelled with this one. Finally we have limit as x comma y is approaching to 4 comma 3 of x minus y plus 1. Substitute x is equal to 4 and y is equal to 3. We have 4 minus 3 root plus 1. This is root of 1. Root of 1 is 1. 1 plus 1 is 2. In this case, we are getting a unique value of limit and that is finite. We can say the limit exists and the value of limit is 2. Next, we need to find the limit of this function at origin. What we can do in this case, substitute x is equal to 0 and y is equal to 0. What we have? 0 plus 0 divided by 0 square plus 0 square plus 1. That is 0 by 1. 0 by 1 is 0. Now this is a finite and unique value. It means this function is approaching to 0 whenever it is approaching to origin. Next question is, what is the limit of this function whenever x comma y is approaching to 0 and 1? So what we can do in this case, if you observe, we have a two different function. One is only depending upon y and another is depending upon x. So we can write this as equal to limit x approaches to 0. The function of x is tan square x by x square, and y is approaching to 1. In that case, the function is y minus 1 divided by y square minus 1. We have just rearranged these terms and this limit we have written in this format. This can be further written as limit x approaches to 0 tan square x by x square into limit y approaches to 1 y minus 1 upon y square 1. As this is not depending upon y, so we have taken the limit with respect to x, and this is not depending upon the x, so we are taking the limit with respect to y. Now it is get converted into one variable. In this case, we know that limit as x tends to 0 tan x by x, this is equal to 1. So we can write this as equal to limit x approaches to 0 tan x by x square, and in this case we can separate this. Y minus 1 into y plus 1. Now this factor is get cancelled with this one. In this case, this limit is 1. So 1 square is 1 into, substitute y is equal to 1. We have 1 by 2. In this case, this function is approaching to 1 by 2 whenever x is approaching to 0 and y is approaching to 1. Another question we have, find the limit of this function when x is approaching to 1 and y is approaching to 0. We can separate this function again into part of x and y. We can write this as limit as x approaches to 1 and y approaches to 0. We have function x minus 1 divided by log of x into sine y by y. Separate this limit because it is independent of each other. So we can write as x is approaching to 1, x minus 1 upon log of x. It is not depending upon y, and the next factor is not depending upon the x. Sine y by y, as y tends to 0, this value is equal to 1. And in this case, this is also approaching to 1. Now, how this is approaching to 1? We know that when you put x is equal to 1 in this case, we have 0 by 0 form. And in one variable, when we have a 0 by 0 form, we are using a L'Hopital rule in order to find the limit. It means we need to find the derivative of the numerator as well as the derivative of denominator. Now, derivative of the numerator is 1. Derivative of denominator is 1 by x. We can write this limit is approaches to same point. Rather than taking this function, we can take their respective derivative at the respective places by using a L'Hopital rule. Now substitute x is equal to 1, we have 1. So this limit is equal to the limit of this function, that is equal to 1 by using a L'Hopital rule. And same concept is basically used in this case, sin y by y, as y tends to 0. So overall in this case the limit is 1, and that is a finite value, unique value. So means limit exists and the value of limit is 1.